Chapter 2, Thermochemistry, Part 2. Enthalpy and enthalpy change. Many reactions are accompanied by change in the heat content of the reacting system. Enthalpy is the system is defined as the heat content of the reacting system. The unit is kilojoule per mole. Enthalpy change for a physical process or chemical reaction is defined as the difference between the enthalpy of the products and the enthalpy of the reactants occurs at constant pressure. The unit is kilojoule per mole. So for any reactions, this is how you calculate the enthalpy change. Concept of enthalpy. The heat content of the system is known as the enthalpy of the system. The total heat absorbed or liberated in a chemical reaction is called the heat of reaction. We cannot measure the absolute value of the enthalpy of the system, but we can measure the change in enthalpy. The experimental technique for measuring enthalpy change is called calorimetry. Calorimeter is a device for measuring quantities of heat. So this is the thermochemical equations. Look at the endothermic. So we look here is the chemical equations and we have the enthalpy of formation. And we look at the sign positive. So this one is the endothermic reactions. For the exothermic, so this is the chemical equation and we have the enthalpy of formation. So negative refer to exothermic reaction. For the types of enthalpy, so this is the example of the types of enthalpy, but we only focus for A, B, and C. So for A, enthalpy of formation, B, enthalpy of reaction, and enthalpy of combustion. Standard state conditions for measuring the enthalpies are temperature of 25 degrees Celsius, pressure of 1 atm, solution having concentration of 1 molar. For the standard enthalpy of formation, the enthalpy change heat liberated or absorbed when 1 mole of a pure compound is formed from its elements at a standard condition. The standard enthalpy of formation of any elements in its most stable form is 0. So this is the example. Look at the most stable form for the enthalpy of formation of oxygen is most stable is equal to 0, and also the graphite. So this is an example. Standard state, a physical state, solid, liquid, or gas. So we look at this in a bracket. So this is the solid, liquid, gas, liquid, solid, and liquid. So this is the example. We will have a different enthalpy of formation. So there is never a compound on the reactant side, only element. So this is the compound. Carbon dioxide, water, compound is not element. So this is wrong equation of formation. So for carbon only and the hydrogen, oxygen for the reactant. So this is the correct equation of formation. A formation reaction involves making substance from its elements and only the elements. It must end up with 1 mole of the compound. For example, the product only 1 mole of the compound. For the standard enthalpy of reaction, the enthalpy change of a reaction carried out at standard conditions. So this is how you calculate same as the previous one. So this one, the sum of the product, you minus with the sum of the reactant. Calculating the standard enthalpy of reaction from enthalpy of formation. Standard enthalpy of reaction is equal with the sum of enthalpy of formation of the products minus with sum of enthalpy of formation of the reactants. So this is the formula. For the enthalpy of combustion, the enthalpy change when 1 mole of pure substance is completely burned in excess oxygen under the given temperature and pressure of the reaction. If the conditions of the reaction are standard condition, then it is called the standard enthalpy of combustion. The value of enthalpy of combustion is always negative. And this is the example. Look at the negative sign here. So this is the exothermic. Calorimetry, the change in temperature of a substance when it is heated or cooled, depends on the heat capacity of the substance. Experimentally, we can determine the heat flow associated with a chemical reaction by measuring the temperature change it produces. Calorimetry is a method for measuring the heat change of a reaction. An apparatus that measures heat flow is called a calorimeter. A calorimeter consists of an insulated vessel in which a chemical reaction or physical change is allowed to take place and the heat release or absorbed is measured. Types of calorimeter: bomb calorimeter, simple calorimeter. The specific heat of a substance is the amount of heat required to raise the temperature of 1 gram of the substance by 1 degree Celsius. It has the unit joule per gram degree Celsius. The heat capacity of a substance is the amount of heat required to raise the temperature of a given quantity of the substance by 1 degree Celsius. Its unit are joule per degree Celsius. Specific heat is an intensive property, whereas heat capacity is an extensive property. The relationship between the heat capacity and specific heat of a substance is heat capacity is equal mass times specific heat. So this is the example. C is equal to the MS. Specific heat for water, 4.18 joule per gram degree Celsius. So 4.18 joule is needed to raise the temperature of 1 gram of water by 1 degree Celsius. For amount of heat transfer to a substance or object depends on mass of the object, its specific heat and temperature change. Heat is defined as, this is the formula. Sometimes you can see the S or C. C is the small letter. But this one, same, is specific heat. So enthalpy change is equal to the heat divided by number of moles. So this is the formula. And you can look at this as the example. How much heat energy is released when 7.1 gram of substance is cooled from 100 degrees Celsius to room temperature 25 degrees Celsius. The specific heat of substance is 0.460 joule per gram degree Celsius. So the solution Q, mass for the substance is the 7.1 gram. So this is the specific heat of the substance and you times with the temperature. So this is the answer. Why is negative? Because this is the heat release. Bomb calorimeter consists of a strong vessel surrounded by water in a container, suitable for determining energy change in reactions such as combustion. A non-mass of the sample is ignited electrically. The heat released by the reaction is transferred to the water and the rise in temperature is measured. Surroundings, so this water and metal parts, so still bomb. Basic principle: heat released by a reaction is equal to the heat absorbed by the surroundings. Heat released by a reaction is equal to the heat absorbed by water and heat absorbed by calorimeter. For the constant volume bomb calorimeter, so this is the image, and you look at the equations. So heat release is equal to the heat absorbed by water and heat absorbed by calorimeter. So this is formula, you can see which one is the specific heat, also the heat capacity, and temperature change in the temperature. And this is the example. A 0.444 gram sample of sucrose is burned in a bomb calorimeter and the temperature increased from 20 degrees Celsius to 22.06 degrees Celsius. The calorimeter contains 748 grams of water and the bomb has a heat capacity of 420 joule per degree Celsius. Calculate the enthalpy change for the combustion reaction. For the heat reactions, we have the negative Q cal means this one, the heat calorimeter, plus with the heat solution. This is the heat capacity 420 joule per degree Celsius, and this is the change in temperature, meaning that 22.06 you minus with the 20 degree Celsius, and you plus with the mass of water 748 gram, and this is the specific heat for water 4.184 joule per gram degree Celsius, and this is also the change in temperature, and you get the answer for heat reaction. Simple calorimeter sometimes is called coffee cup calorimeter, suitable for measuring enthalpy change for reactions that take place in aqueous solution. The outer polystyrene cup insulates the reaction mixture from the surroundings. It is assumed that no heat is lost to the surroundings. Basic principle: heat released by a reaction is equal to the heat absorbed by the surroundings. Heat released by a reaction is equal to the heat absorbed by solution plus heat absorbed by calorimeter. Constant pressure calorimeter, so this is the image. A constant pressure calorimeter made of two styrofoam coffee cups. The outer cup helps to insulate the reacting mixture from the surroundings. Two solutions of known volume containing the reactants at the same temperature are carefully mixed in the calorimeter. The heat produced or absorbed by the reaction can be determined by measuring the temperature change. And this is the formula. Methods of enthalpy change calculation. Number 1, using formula direct method. So this is as usual, you know already how to calculate, use this formula. And second one, algebraic method, indirect method, using thermochemical equation, HESS'S law. Third one, energy cycle method, indirect method, using the HESS'S law and Born-Haber cycle. For the standard condition for calculating enthalpy change, The numerical value of enthalpy change is influenced by 5 factors. First one, the temperature at which the experiment is carried out. Second one, physical state, solid, liquid, gas of the reactants. For example, the reaction between solid iodine and hydrogen is endothermic, but the reaction between gases, iodine, and hydrogen is exothermic. The third one, allotropic forms of the reactants. Next is the pressure of the gaseous reactants. And the last one is the concentration of the reactants. The standard conditions for measuring enthalpies are temperature of 25 degrees Celsius, pressure of 1 atm, solutions having a concentration of 1 molar. For the formula method, for the direct method, so the standard enthalpy of formation of any element in its most stable form is 0. Algebraic method, indirect method, rules in using thermochemical equation. The stoichiometric coefficients always refer to the number of moles of a substance. If you reverse a reaction, the sign of enthalpy changes. If you multiply both sides of the equation by a factor n, then enthalpy change must change by the same factor n. The physical states of all reactants and products must be specified in thermochemical equations. Rules in using thermochemical equation. The stoichiometric coefficients always refer to the number of moles of a substance. So this in front of the water, actually 1, so this is the coefficient. Same goes here, 1 mole of the water. If you reverse a reaction, for example, liquid go to the reactants and the product is a solid, so you must change the sign of the enthalpy change. If you multiply both sides of the equation by a factor, then enthalpy change must change by the same factor. For example, you multiply with 2, so the enthalpy change also same. The physical state of all reactants and product must be specified in thermochemical equations. So you must specify for the physical state of the reactants and also the product. For example, the water here is the solid, so you must write S here. If the product is the liquid, so you must write the L. How much heat is evolved when 266 grams of white phosphorus burn in air? So this is another example how to calculate. So actually this one is the enthalpy change. Hess law states that when reactants are converted to products, the change in enthalpy is the same whether the reaction takes place in one step or in a series of steps, provided the initial and final conditions are the same. Hess law steps involved in solving enthalpy of combustion problems, balance the individual equations, if necessary look up standard enthalpies, flip equations around if necessary to cancel out terms on opposite sides. Changing the equation around requires a sign change of the enthalpy of that individual step. Sum up the individual steps. Calculate the standard enthalpy of combustion of the transition of graphite to diamond. So this is the thermochemical equation. Equations are balanced. No need to flip an equation around because it is possible to cancel out a couple terms as is. So we look reactant as the graphite. So this is also the graphite in the reactant. So for the product, it's a diamond And here the second one also, product is a diamond. So no need to flip an equation. Cancelling out the oxygen and the carbon dioxide species like this one and writing the overall reaction. So summing the two enthalpies together, so this is the answer of the enthalpy change. And we done chapter 2, thermochemistry. Thank you.